Hey guys, in today's video I'm going to be going over the nomenclature on alkenes. So it's different than alkynes. We're dealing with double bonds now in this new chapter. So you can see right here the ending changes. So the suffix goes from ane to ene. So we were looking at alkanes, which has ane. Now we're dealing with alkynes. So that's a dead giveaway that your ending should be something like that. So you can see right here we have heptene instead of heptane. If we wanted to say ethane, it'd be ethene. And we could go, as it says right here, we go pentane, we could go butene. So just change that ane to ene. And that's the one, a change with the parent chain, that is, just with that parent chain. One other rule that I have right here is that even though you might have a hydrocarbon chain that has more carbons, if it doesn't include that double bond, then it can't be that parent chain. So even though we have 1, 2, 3, 4, 5, 6, 7, 8 carbons right here, that cannot be the parent chain because it doesn't include this double bond up here. So even though it might be less carbons, it still has to include that double bond because that double bond has pretty high priority. Okay. Similarly, with that double bond, it has priority over the methyl groups, which we saw before, and it has priority over those halogens that we saw previously as well. So for numbering, even though you might have better numbering with a methyl group or something like that, you would still choose to set those double bonds at lower numbers as it shows right here. So nothing really changes out here except for placing this number to indicate where that double bond is. So you have to place that number, and it says right here, you can place it in 2 different places. So you can say, obviously these are all your substituents, and a normal IUPAC nomenclature would just go right into the parent chain and not have another number, but we have to indicate where that double bond is. So you can either do it before the entire name of your parent chain. So in this case, it's heptene. You could do 2-heptene, or you could do hept and then put a 2 right there to really indicate that there is a double bond on the 2 position, and then do the ene. So whatever works. If your professor prefers a specific way of doing it, obviously do that, but these 2 different ways are both perfect. Similarly, in naming, there's the cis versus trans. So you guys went into this when you talked about stereochemistry and regiochemistry. They kind of coincide with cis versus trans. Remember, is this cis or trans when I draw it like that? What do you guys think? Is that cis or trans? That would be cis, right? Because your 2 groups are both pointing upwards from the double bond. So that would be a cis. And I felt that this was a good little practice. Cis, you can think of it as same side. So same side. And that is the Z. So when you go in naming and you have to indicate if that double bond is cis or trans, cis would be Z. So you would put a Z before anything else. Okay, and then for trans, it's E. There's not really a good way of thinking about that. An example of trans would be if you have something like this. So this is going down from the double bond, and this is going up from the double bond. So they're going in 2 different directions, you could say. Okay, so that's this first trans. Let's get to some practice problems. Feel free to pause it if you need some time to go through it, but I'm just gonna dive right in. So 1, 2, 3, 4, our parent chain has 4 carbons with no substitutes or substituents, I'm sorry, and we want to set this double bond as the lowest priority. So we want that double bond to be our carbon 1. So this would be 1 butene, or you could do but 1 ene. Okay. So our but comes from our parent chain, the butane, but since we have that double bond, you have to add the ene, and you have to specify where it is in butene. Because if you didn't specify with that one, this would be butene as well, but this would be 2-butene, right? Because it's on the 2 carbon instead of that 1 carbon. So you really have to specify with that number the position of where your double bond is. This could also be but2-ene as well. You could also do that. Let's try this next one. So we have 1, 2, 3, 4, 5 carbons. So that's going to be pentene. So right away we can write our parent name, and we can put ene because there's the indication of those double bonds. And I'm going to start the numbering over here, because if I didn't, our 1 carbon would have no double bond, and we want the lowest priority, the lowest numbering, so we want to start on that other side. So how would you name this? I would start by doing 1, 3 pentene. And obviously I haven't been putting the Z and E. This would be, let's see, this would be a E, so 1E, and this would be 1E, 3E. You'll have to check with your book on how they go about this, because this chapter is really interesting, as they don't tend to put your Z and E, those trans and cis, till later on in the book, at least at the book I'm looking at. So you'll have to really see if they really put it there for this chapter, or if your professor specifies those Z and E in your IUPAC names. All right, let's go on to this next problem. We have, let's see how many we have in our parent chain. We have 1, 2, 3, 4 carbons. And why did I pick this route instead of this being my 4th carbon? Well, we have to include this right here, and we don't have a name for, if we chose this other route, we don't have a name that goes from methyl to bromine, so we have to choose that other path. So we have 4 carbons, that's butene, and we can put ene because of that double bond. Our double bond is placed at the 1st carbon, so we can do 1. We have a methyl group, so we have a 3-methyl right here, and we have a 4-bromo. So remember, alphabetical order for the substituents, so we would want to start with our 4-bromo, and then do 3-methyl, and then 1-butene. You could also write this as, and I'll rewrite it, 4-bromo, 3-methyl, but 1-ene. And this would again be a E for both, if you're required to write the Z and E. Okay. And that pretty much wraps up alkene nomenclature. You don't really get into tough nomenclature until you get into putting all your components together, when you get into the alcohol chapter or maybe the alkyne chapter, and then it really starts to get difficult. But this is it for nomenclature of alkenes, and I'll see you guys in the next video.